Hi, everyone. Welcome to the Global AI Community APAC AI version. And today we are going to have a Microsoft AI MVP, Priyanka, talking about Azure Cognitive Services in Language Studio. Microsoft AI MVP, just apologies, I have a YouTube behind the scenes. Azure Cognitive Services in Language Studio. Another one. All right, that should be. Apologies for technical issues. All right, so first, who we are. So APEC AI community, you can find us on LinkedIn, Meetup, and you can also use GitHub to publish your own request to do a talk at APEC AI on these issues. And you can also follow us on Twitter. And for today, we are not going to cover news. We're going to go straight to a regular session. And at the end, we're going to have a bit of a Q&A with the presenter. So I'm now going to leave Somi to do the introduction of the presenter.
Thanks, JK. Hello, everyone. Thanks for joining us tonight. I'm super excited to have our guest tonight. Priyanka Shah accepted our invite to be our guest for this session. She's Microsoft AI MVP, and she's a solution architect as well as a manager, and she's been doing a lot of work in the technical and the IT community as well. So I'm going to bring her up, and then we'll have a little chat before we jump into the session. Welcome, Priyanka.
Hey, thank you, Somi. Thank you for having me here. Hey, guys.
Thanks for joining us tonight. How has your day been?
Well,
I guess we are caught you in
usual.
the middle of your day, right? What time is it there? By the way, she's joining from Singapore.
Yeah, that's right. Yeah, so it's around 2:45 here, 2:39 p.m. And yep, so I'm bang in the middle of all client meetings, pre-sales. Yep. So
Oh my goodness.
I've reserved 1.5 hours for a focus time, a me time in which I'm doing this.
Awesome. Thanks a lot for joining us tonight. I'm super excited for your talk tonight. So without further ado, I guess I will pass it on to you to just start your presentation. And if you get time, we'll have a little chat at the end.
Sure, absolutely. Let me share my screen. Oh, I'm already sharing screen, is it? Can you see my screen already?
No, it's not in the. I can bring it up whenever you're ready.
The screen is already shared. I think you're sharing the wrong screen. So you're sharing currently this screen over here.
But okay, let me stop screen. Let me share again. Share
Yes.
screen and then share. And I will say entire screen share. Okay. I think you need to bring my screen sharing also into live mode.
Yeah, so this is the screen we're currently seeing. Okay, seems to be good. Yeah, we can right now see the PowerPoint.
Yeah. I'm just trying to bring up the correct PowerPoint. In my end, it is hanged. Yeah, okay.
Okay.
All right. Okay, jumping in, yes. All right. Okay. So let us delve into the nitty-gritties right away. So I'll be talking about introduction to Azure Language Studio, how it is different from what previous cognitive services we had with Azure. And we will see a lot of demos today, live projects, some of the demo included in the Language Studio itself, and keep it interactive. So Somi or whoever is monitoring the chat, right, please feel free to interrupt me so that I can interact and answer any questions right away, rather than keeping it at the end. All right. So this is about me. I am currently leading the growth markets in Avanade. Okay, and I am working as the AI IoT offering lead. I am a Microsoft AI MVP, and you can connect with me on my LinkedIn and Twitter handles anytime. All right. Okay, so this is the agenda for today. We will be looking back at NLP offerings from Azure and what kind of motivated them to come up with the Language Studio. Then we'll look at cognitive services language suite and some popular NLP models like OpenAI, GPT, BERT, and we will see some demos with them. All right. Okay, so when we talk of Azure NLP, right? So a few years ago, when Azure came up with their beautiful cognitive services, and we had something called as text analytics. We had conversational AI, which was made possible by language understanding integration services, and we had a Q&A maker for your technical Q&A FAQs. Okay, so these were the classic forms of NLP and not very powerful at that. I mean, if you started sort of experimenting with them, they could do only so much. So for text analytics, maybe very lesser amount of entity extraction or named entity recognition, right? And if you wanted to do anything custom, so like custom tagging, defining your own entities, that was a bit not possible, and then you had to rely on other NLP like Spark NLP, sort of advanced NLP models, right? So these were our cognitive services which we remember and which we use. Okay, so which were in language, we had language understanding, text analytics, Q&A maker, text translation. In speech, we had speech to text and text to speech, speech translation. Okay, and the others are like web search, decision, vision, and again I won't touch on these, but even these have got undergone a huge amount of drastic change, right? Like a revolutionary change with new features and new things. So especially when we talk of language and speech, the Language Studio has made taken immense strides with the help of OpenAI GPT paradigm, and then brought in a lot of innovation there. Okay, so
Apologies, Priyanka. Can you, right now we're seeing the presenter mode. Can
oh,
you
okay,
set up
hold on.
this one to swap?
This is okay.
Thank you.
Okay, all right. Okay, great. So okay. So why now we keep on talking of NLP? I mean, why would a natural language processing be such an important thing? So as you know, right, I mean, more and more information comes, and you have this information explosion. And in enterprises nowadays, they come to us with a use case that we want to have an intelligent knowledge miner, or a knowledge finder within intra enterprise. Okay, so banks come up to us saying we should have a sort of intelligent assistant that can help your bank employees or even customers to do some sort of initial KYC kind of thing. Then we have oil and gas people coming up to us to tell us that, hey, we have whole lot of documents about our departments like sand management and HSSC and XYZ things, and then we want you to help us with searching those. Okay, we have project management firms come up to us and say that we have a hell lot of documents dispersed around various areas, and then we want one person to be able to, our users to be able to search them intelligently. Okay, so which is why when either by the means of a text interaction, or by the ways of voice interaction, more and more enterprises are wanting to make sense of the data which they have, and have a sort of an intelligent, automated, intelligent engine sitting in between for the users and the data which they have to interact with each other, and which is possible only via NLP, natural language processing. So the engine or our ML program, it tries to make sense of what we are trying to search, what we are trying to say. And as as engines and algorithms become more and more intelligent, even the end user demand increases a lot more. So a couple of years ago, we were happy with just having keyword searches, right? I mean, keyword hits. So if I search for I mean, if I had a music website and I search for a particular artist, okay, or particular album and a particular band, then only documents where that particular keyword is there present, only those could be fetched. So that was a very targeted keyword key phrase search, right? Either keyword or key phrases. And then it was possible with the help of engines like you had Elasticsearch, and you had Solar, and you have right now Azure Cognitive Search. But even all these NoSQL inverted indexing engines also became super intelligent over the years. And right now we are at a stage where people want word semantics and extraction of relationship between entities. Okay, so what does word semantic mean? Semantic means, so right now we are working for a use on a use case for an oil and gas conglomerate. And the use case is that if I'm trying to search documents with the word, like for example I'm searching for energy saving techniques, okay, then I should also be presented documents which may not have the exact same phrase or term, but then are semantically closer. So if I'm trying to search for energy saving mechanisms, okay, then I should be presented with renewable energy documents, or documents which are talking of, environment friendly oil drilling techniques, or energy saving equipments in, oil and natural gas processing, these kind of things, solar energy, tidal energy, green energy. So interchangeable word synonym search, semantic word semantic search, these are the next generation intelligent things which, end users sort of expect. Okay, so that is why we are in the middle of a paradigm shift, just from search driven to now an intelligent all knowing enterprise. All right, now when we talk of, more and more data, so we absolutely know that there is a data explosion, and then which means we spend a lot of time in searching, or if you don't, right away hit the exact keyword, then you are spending a lot of time searching the perfect word to sort of pop out the correct document. Okay, so for example, you will spend a lot of time in guessing or the search term correctly. And then typically it happens in your emails also, right? I mean, you remember that I had some mail some time ago, and then you don't know the exact email ID, and when you're searching the inbox, you're fumbling with the keywords, and then, hit and try sort of thing. So much the same thing also happens with search engines, where, which are not intelligent and which are with limited vocabulary, limited capabilities. Then this is more often than not the unproductive time spending in searching. Okay, all right. And what are the enterprise challenges with data? Okay, so of course, how do you enable your workers also to contribute to become a part of your intelligent enterprise? So you have improved collaboration between SMEs, okay, or between experts. Okay, you have intuitive user interfaces, then you have personalized searches, which is another big thing, right? I mean, people want to have personalized content on their dashboard, and that content should also evolve as and when the person evolves, or his tastes undergo a change. And then consolidation of content platforms, like a golden data source sort of a thing. So data lake, the term data lake got traction a few years ago, not too long ago, but then that was a consolidation of all the content platforms. And then it keeps on evolving, like we always have a question, what else, what next? Okay, what next? So to address all of these challenges for text analytics, or analyzing text, and then analyzing the relationship between different documents, making it dynamic summarization of documents. So we also come across a lot of use cases where enterprises typically come to us saying, I have documents that run up to like 20-25 pages, which are probably, your customer profiles, or some sort of reports of your clients, right? And then they just want to have a summarized view of that. In short, in a very short paragraph, just tell me what my document is talking of, and I get a gist of it, and then I know whether this is what I want, or I should move on to the next document, right? So this kind of dynamic text summarization, just if it try to put it into perspective, just imagine that as a human, if you were to paraphrase or summarize something, it is, I mean, it is hard as it is to capture the essence of what your text is saying, and then you add to it the complication of a machine trying to do that, right? And then you will try to I mean, you will then begin to appreciate the beauty of all these powerful NLP models and how they really come together to give us a holistic enterprise an intelligent enterprise experience. All right. Yeah, as I was saying, right, so when we have to build these kind of a text analytics intelligent and all knowing intuitive engine, which is where all your offerings come into play. So you have summarization, you have text classification, you need to have conversational AI, where you are interacting with your engine in the form of a bot. Sometimes it could be a search interface, sometimes it could be a voice assistant, where someone is speaking commands via their devices, right, and then that is being translated, and then that is being interpreted using NLP, and then your search results are rendered back to you, right? So there are various ways in which you can interact, and then various forms of interaction. So sometimes you will need a combination of all of these things. You will need, like, semantic search, as well as chat bots, as well as dynamic text summarization, text classification, entity extraction. Sometimes it will be very specific, like I might just need to do a dynamic summarization as well as text classification, plus be able to identify custom entities. Okay, so keeping into mind all these different permutations and combinations, Microsoft has come up with this Azure Cognitive Language Studio, which is a combination of various offerings that you can use in tandem with each other, or as separate standalone offerings. So we will see use cases where these services are operating together, collaborating together to bring us a holistic experience. And we'll also see standalone cases like just a Q&A bot, right, like which is a dynamic thing. Okay, so dynamic Q&A bot. And we'll also see certain things where it is few services are working together to give us a knowledge graph kind of a functionality. All right, moving on. So when so the use case which today we will be discussing is about how to combine the services alone or together to build a enterprise knowledge finder kind of an experience, right? So which means, what does an enterprise knowledge finder do? So it is an AI assisted search, correct? So which means it will gather your data sources from all your on prem or your legacy or your on cloud SharePoint and file systems, to bring it together in a central location, ingest it into your platform. Okay, and then allow NLP queries to run on your data, and then give you your preferred results. Okay, and then it could be running across, I mean, indexing documents across sources. The documents could be text or audio or video or images. Okay, then that engine will also do a summarization and preview, or a dynamic summarization of your documents, as I said, right? Like documents running typically into a lot of pages, there's a short AI generated summary of that, capturing the essence of what your document is trying to tell us. Feedback and analytics, meaning more often than not, AI being an algorithm, a machine, it will need feedback for the kind of results it is surfacing back. So try as you might, right, there is only so much refurbishment, refinement which you can do to your algorithm. So even if I have all the state of the art things, sometimes the search result is still not exactly what I'm looking for which there is a feedback given to re-rank your results, or to tell the to tell the model that it is not doing so well, right? And then we have the possibilities of reevaluating, improving, and retraining our model. So that there's a feedback loop for, and which is also typically what you see in our social media platforms, right, where you are rating the search results, you are indicating by way of thumbs up or the number of stars that how relevant was this search to you. And that is actually a reverse feedback loop. It trains the algorithm, and it tells the algorithm that how relevant it was, and how I mean, is this a relevant search result, and should it retrain itself or re-rank the search results, right? So this is a feedback analytic loop, also very important in a knowledge engine, knowledge finder search engine. And then it can do a video and image search. All right, and then a personalized search as well, correct? So based on your user profiles and patterns, it should be able to personalize your settings, personalize your search dashboard, right, those kind of things. And such kind of a knowledge engine, it helps to achieve 15% increase in employee experience. So this is a real time feedback which, wherever we pitch this knowledge finder engine with the combination of all the cognitive language services, this was the feedback we garnered, right? So 15%, they said that, they have improved experience in finding relevant content. So I no longer they need to fumble with the search words. You also have, auto completion functionality. So if I'm typing for like, a medication like ibuprofen, so if I just type IBU, the next of the word is an auto suggestion for me, and I can, choose from an auto completion list of words to check what I'm looking for. Okay. And then this is what people actually tell us, that, it is also a, it is also great that I can review the synopsis before opening the document, which means, a dynamic summary, a peek into your document contents before you actually open the document and browse through it to see if it is relevant to you or not. Okay. So these are all the feedbacks we've gotten from actual people who, for whom we have built these kind of solutions. Okay. And how this knowledge engine works in the background is, you have your data, so data in various formats: audio, video, text, images. Okay. And across various data sources. Okay. And you ingest them, enrich them, enrich them by the way of synonym terms and term boosters. Then you index them, and then, you apply advanced NLP models. Okay. So you ingest the data, you enrich the data, you apply advanced NLP models for entity extraction and named entity recognition. And finally, the the index data in whichever indexing engine you are using, whether it is Azure Cognitive Search or which or Elasticsearch, right? And finally, you expose it to the UI to explore. Again, on the UI, there will be some sort of NLP functionalities to translate the user input into some sort of format to which is understandable by the cognitive search engine. Okay. The indexing engine. So this is a very technical representation of how it works in the background. We will look at some of the features, the demos of how it is going on, the processes which are going on in the background. All right. So before we go there, okay, I would also like to show you some of the use cases for this kind of advanced NLP. So imagine that you have all these intelligent services with you, which is text summarization and text classification and custom named entity recognition. Okay. And then we use I mean, what are the use cases for that, right? So we have infographing. Infographing meaning, visualization of your contextualized information. Then bundle content, which is dynamically grouping semantically similar content together. So this is typically unsupervised machine learning, in wherein I throw documents at the engine, and then the engine is bundling them together depending on the contents and the context which they are talking about. So a lot of higher order NLP goes in there, wherein you're using topic modeling and you using semantic BERT and all. Okay. Then of course, solving our normal NLP problems. Okay. So which is your day-to-day interactions which you have with your bots, so having intelligent dialogues with your end user. Social collaboration, correct, of course, yes. And then getting the best information in a blink of an eye, like before you can bat your eyelid, and you click search, and you should be getting all the information which you want, right? And then again, next best action, which is again what you typically see on your social media platforms, right, where you are buying something and then you're immediately suggested that people who brought this or people who watch this also watch this kind of a thing. So next best action to do. And then auto crawling, so which means if some particular piece of information is missing, instead of me instructing the engine to go and search it, if at all the engine can decipher it itself and then do auto crawling of related content, then that is like the next gen intelligence which we want. So right now we have all of these. We have infographing, bundling, NLP, of course, social collaboration, yes. Next best action, yes. Recommendation engine, yes. But I mean, this kind of an auto crawling feature is still not out of the box with Azure. Okay, and it is still, we have to rely on lot of your third party AI models and techniques there. And then it is people centric, meaning finding the best people related to a topic, right? So if I'm talking of electric cars, then of course it should be Tesla who should be thrown into the mix. So depending on the topic which I am searching, it should automatically give me the best matches and the best context for my searches as well. Okay. So, with all these background information of our requirements of our intelligent enterprise engine, let us move on to the Azure Cognitive Services for Language. Okay, so what is that? So, all the previous services which we had, right, like text analytics cognitive service, and then you had Louis.ai platform, much like the custom vision.ai platform. So Louis.ai and Q&A Maker, all of them have been now combined into a platform which is called as the Language Studio. Okay, and that Language Studio, we will need a language service, a language cognitive service resource to be created. Then we have a Language Studio portal where we navigate to using our Azure subscription, our main Azure subscription, signing in with our Azure credentials. And then we then it is it we will see that, I'll demonstrate it. We will see a portal where we will be able to have all of these functionalities which already we had in our cognitive services. So text analytics is also there, but as you see, this is a next generation, so it can do much more than what your precursors could do. Okay, so text analytics could give you keywords, key phrases, and entities. The Language Studio also can do that plus more, right? So plus now you can do custom text tagging as well. So you can tag custom text, you can classify custom text. And then there are new features which are not hitherto given to us in cognitive services. So we have text summarization, and we have custom text classification, which where we can, these are the new things. And then of course you have your language understanding, so conversational AI, and we have our good old Q&A Maker. Okay, but again, whatever was previously existing is more powerful, and there's again more you can do with that, with the help of all custom classification and custom NER and custom tagging and a lot of things. Okay, so yeah, so this is just an introduction about your cognitive services Language Studio, right? So it is pre-configured, which means some of the AI models are out of the box, and then customizable, meaning you can also train out of the box models with our own data, right? Which feeds our own use cases, custom use cases. And then of course it is, it is comes in both Language Studio, so you can do it on the portal itself, you can do it via SDKs, you can use it as REST APIs, right? And what it is, so it's a state of the art capabilities, of course, right? Multilingual models, correct? Then visual interface, so people who have been using custom vision.ai portal and all, we know that we can train the model on the UI itself, I mean on the portal itself. And then of course data safety privacy is guaranteed, because this is all governed by the responsible AI paradigm. So before you create all these services, we are asked to agree to certain terms and conditions, like we agree to it that our data is safe and protected, and I will not use it for any malicious purposes and stuff like that. So of course it is governed by the ethical responsible AI features. And then these are some of the features of Language Studio, correct? So this is like end use cases for what we will use Language Studio for. So with conversing with customers, yes. Processing of medical text, especially because Microsoft has come out with a health AI model, a health bot, a health model. And then automated workflows, which where you can classify your documents, and then you can custom tag your documents, comprehend information faster, of course, right? Getting in, understanding, ingesting and conveying information faster. Better understanding of customer. Okay, so especially when you are ingesting documents about your, for example, opinion mining and customer reviews and stuff like that, that gives you a better understanding of your target customer, right? So as a hotel enterprise or as a retail enterprise, if I'm trying to do opinion mining of all the customer sentiments about my brand or my product, then of course, having these kind of a feature, Azure Cognitive Services unearth sentiments, hidden sentiments and stuff, I would be able to get a deeper understanding into my customer base there, and how to design campaigns around retaining customers and stuff like that. All right, so enough of talk. Now let us go into some of the the visual show and tell, some of the existing projects which we have, where we will will I showcase semantic capabilities. So semantic question and answer functionalities. Okay, and then we jump headlong into the portal itself, where you can see in action all of the good things we just saw about Language Studio. All right, so let me go back. Oh, come on. All right, so before I can use the Language Studio, I am signed in to my portal, Azure portal, with my personal credentials, and I need to create a language resource. So as you can see, I created a language resource, and using that language resource, I will be entering my Language Studio. Okay, so for the Language Studio, you need to go to this language.cognitive.azure.com. You log in with your credentials, and then for the initially, before loading the portal, it will ask you that which of the language resources you have created in your portal it should use, and then there'll be a drop down, and you can select the language resource which you had created, and voila, this is your Language Studio. All right, so these are the few projects which I have created. I will also show you, so once you land on this page and you don't have any projects here, this section will be blank. Okay, and what you have is what functionalities the Language Studio can do. So it can extract information which is personally identifiable information, extract key phrases, find linked entities. Okay, we'll shortly see what are linked entities. All right, then it can extract named entities meaning names of people and landmarks and celebrities and organizations, right? So those kind of things. Extract health information, so especially in COVID times, when we are seeing a lot of automated bots trying to process COVID related symptoms, COVID related health reports. Okay, so these kind of health information extraction. And then custom named entity recognition. So all of these things which you see, right, extract p2, key phrases, find linked entities, these are all out of the box, meaning if something let's say you wanted to find few other entities from your text. So let's say okay, let us jump into it, and then we will see, like what I see by say what I mean by linked entities or named entities. And then we'll also see custom named entity recognition, so how you are identifying custom entities. All right, okay. And then you can do sentiment mining, so garnering sentiments, and then checking whether those are positive, negative, neutral. Language detection, so it could be anything from one detection and translation as well. Custom text classification means classifying text on the fly. And then finally you have your language understanding things, where you can have a Q&A bot, you can have custom question answering, you can have conversational language understanding, and then orchestrating workflows. Okay, so making a dialogue flow system where you can navigate from one question to another. Okay, so let us check out some of the information. All right, so when we are saying you want to extract and of course you have summarization of text as well. So let us look at text summarization. So what we will do is we'll look at some functionalities individually. Okay, so we will look at some of the classify text or extract information or summarize text, and custom named entity things one by one. And then what we will do is we will look at few applications I have running here, which we have developed as POCs for our potential customers, and we will see how all of these work together. So how we are identifying entities, relationship between entities, what does linking entities mean to us. Okay, so we will also see end to end working demos for all of that. Okay, so let us first try to understand when I'm saying extract information, right? So extract information, maybe we will first try to see find linked entities. Okay, so I'm going here, and then the beauty of this portal is you can directly experiment with your own file, or just to experiment with the studio and understand the functionality. You also have some samples given here itself, and then you can work on top of that. All right, so this is my language resources which I have created, and text I can select, or it can be auto detect also. You can put auto detect language, and whatever language you put here, it will be able to detect that. So I'm putting select language is text. Okay, then you can either enter your own text, upload a file, or use one of our sample text. All right, so let us for example, when we are extracting linked entities, let us look at some of the some of the documents which it already has. Okay, so this is a very simple document. Of course, in real life your documents won't be so short. Okay, so I will give you one music demo which we have created, in which we have gathered Wikipedia, open source Wikipedia text for music albums and genre, and artists, music artists and stuff, and then they typically run into like a couple of hundred lines here. Okay, so anyways, so what it is trying to do is, a trip to Alaska is simply incomplete without experiencing the Denali National Park, which is North America's tallest mountain, blah blah blah. Okay, so this is something about a travel information. So sorry for that. Okay, and then what I'm going to do is I'm going to run this, right? And then the result will be given in the form of JSON as well, which is when you will consume it, especially when you're doing it via REST interface. Okay, or then it can be shown you right now. Here you can see it as cards. So what it is doing is, it is trying to it is trying to see it is trying to extract entities. Okay, here linked entity, linked entity, linked entity. Okay, and what it is trying to do is, see, it is trying to extract entities, and then it is trying to link them. Okay, so Alaska, it extracted as entity. Then Denali National Park is another entity. North America, North America's, okay, so North America it extracted as an entity. And then Alaskan range it extracted as entity. Probably there are other things also which could have been extracted, right? For example, this information about 20,000 foot. Okay, so what that is the altitude or the height of the Denali National Park, where it is situated, something like that. Okay, or the Denali mountain, where it is located, tallest mountain, which is 20,000 feet. Okay, and and this is how it will be. And if you click on that, it will give navigate you to that Wikipedia linking of that. So if you click on Alaska, it will give you Wikipedia navigation to that entity. Okay, and this is called as tagging. Okay, so it has recognized entities, and this is called as tagging. Now this is out of the box, we can also do it by ourselves. Okay, so as I said, some of the things here are out of the box, some of the things we can define ourselves to tag it, which is the custom named entity recognition. So let us go here. So what it is particularly doing here, it is extracting information about some important entities which has extracted. Now when I say entities is names of people, person, organization, mountain, landmark, celebrities, and other famous places. All right, and it is based on some of the pre-trained models which is already trained to recognize all these kind of names and people, places, things, and then it is recognizing those. Apart from that, if I have a custom text where I don't have any known entities or stuff like that, Like for example, like I was saying that I have an oil and natural gas client, and I have all the documents about their oil drilling equipments and their types, in which none of those the trained model, the out of the box model, knows how to identify them. So what does a mf 236 mean for that, mean for my text, right? So I need to indicate that this is a type of an oil drill, this is a variant of a oil pump, okay, something like that. So for which I will be using custom text recognition, custom text tagging. All right, so let's go back.
One question, Priyanka, before
Yes,
we go
yes,
back. So in the
yes.
sample that you showed, you put paste the text file. Can
Hmm.
it like recognize the unstructured data, or for example, image or PDF?
Can it
It
can, it
can.
can.
Okay.
Yes, but that image, so image won't be a part of language, right? So
Yes.
image tagging will be a part of your vision. So there is a computer and custom vision
It's
services.
a
So
separate thing.
yes, so that's a separate thing. So of course, you know, you can, I can, because that question came up, I can also show you it is possible, right? So let us quickly look at that, just to get this out of the way, and then, you know, to make it clear about what is. So exactly what people asked, right? So this is an image, and I can extract tags about the image also as well, and then generate a caption also about that image. So you see here this image, and it has identified that this image has water and cityscape and skyscrapers and
Yep.
reflection and sky. And then it can come out with also tagline, and also sort of censor the content, where, you know, does it have any adult content, any violent or racy content, right? But then that is a part of computer vision. We
So
are
if there's a
covering
text,
language.
I understand. So if there's a text within the image, or if it's a PDF, we'll go by computer vision or custom vision. So we'll go
Right,
by OCR detection.
right, exactly. Yes,
Thank
yes,
you.
right. Okay, so again, you know, if your documents are a combination of text and images, then when you're indexing your documents, then you can still index the images. So images will be converted into a base 64 format as well. And there are out of the box OCR services to recognize your text within the images. Also, when you're especially indexing your documents using Azure Cognitive Search, you can do all that. So your document can be text and audio and video and images together. The way they are interpreted is different. So I will have language services doing my bidding for text analytics, and I will have other OCR and image services doing my bidding for my image tagging and recognition. All right. Okay, so let us look at yeah, here, let's extract named entities. All right, so this is, oh sorry, this is again out of the box. Okay, so let us look at a custom example where I'm going to tag custom entities. Okay, so here I created a project custom NER. You can create a new project also, since something was already existing, I just created that. Okay, so for a custom entity recognition, now what I need is, I need to have a data set here. So what I have here is, I have a novel data set. Okay, and for that novel data set, now I can train my own for example entities, right? So I will add few entities here. So let's say in a novel, I will have the protagonist. Okay, then I can have the age of my characters. Okay, I can have the age of my characters. I can have a particular let's say era. Okay, where the novel was written. Okay, I could have an entity, something like who is the antagonist, who is like, who is the negative character here. Then I can have the author, okay, of that particular uh, movie summary. Okay, and a lot of other things, right? I can have the plot. Okay, so a plot point. Okay, plot point. Okay, this is my entity. So entities are like classes which you can identify, right? So for example, and then you could have the what you can say, some city in which that city setting in which that movie took place, whatever is it. Okay, you could have something like, um what you can say. Yeah, let us keep it simple. We can come across a lot of things here. So what I mean by entities is, let us for example, for one moment think that we are looking at a music demo wherein we have the information about artists, the information about their albums, and the type of genre they represent, like hard rock, metallic rock, soft rock, pop, that kind of thing, right? So then the type of instrument they play becomes one entity, wherein if I'm saying that XYZ plays drums, so drums becomes my entity, so which means that is a type of instrument. Or the type of album he is released, the name of the album. So the Beatles released an album XYZ in the year 1996. So year can be an entity, the album can be an entity. So I need to define. So like in the previous sentence, which was out of the box, where you saw that Alaska mountain to the height of the mountain, all these were recognized as entities. Then same way we can define as many entities as we want, and then we can tag here to tell to to train our model to be able to identify entities in a similar setting. Okay, so see, you can see here, right? You can tag this as age. So 14-year-old was an age. And then Danny O'Neill, okay, so he is a protagonist of my story. And then his this Miss Peggy Noble is again another central character, so she's also protagonist here. Okay, and then she's engaged to a cold temper and vicious gym teacher Roy Kilton. Okay, then Roy Kilton is the antagonist here, right? And then blah blah blah, all of these things. So you just get a gist, right? So how you can tag this. So what is the plot point? The plot, you can tag something here, like for example, where is that? Or you can the city where it takes place, right? So you can tag something where the city where it takes place, and then you can tag all of these things, right? And you can take it as a plot point. So this is a plot point. Okay, so the entire sentence. So you can not only tag single words, you can also tag an entire sentence and make it as a plot point. And you can save tags here. Okay, then also you can retag. So let's say you come back and you feel that, oh, this is all nonsense what I've done, or you identify more entities here, then of course you can come back and retag your entities. And I can do this for all the documents. So here, for example, scenes from a night, right? So here I can, as you can see, the Polish artist Julia and her husband Piotr live in Krakow. Okay, and Julia blah 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 blah. So we can see here Julia and Piotr are the protagonists, and then the city is Krakow. So I can tag this as a city here. Okay, so this is a city. So it is so intuitive and easy to tag, right? And this is normally how your annotation labeling tools for all your custom things go. So if, whether you're tagging images or whether you're tagging text, right, we have all these annotation tagging tools to get your data ready for modeling. So this is how you're going to, so this is all your custom data, custom text, and then you're going to define your entities. Could be whole lot of entities. I mean, I have seen projects run into like probably 80 to 90 entities, which is normal, which is still a moderate size, right? And you can, because you, as you can see, right, you have a lot of text here, and then it's not atypical of enterprises to have humongous amount of entities here. So once you tag all your documents, okay, so let us do that. So Polish artist Julia, she is a protagonist, and husband is a protagonist as well, right? So you keep on tagging all of these things. It's a manual process, of course, but this is what your data scientists or your data modelers do beforehand, before you are actually training the model. So once you are happy with your model, okay, so I will need to tag at least 5 to 6 documents here. Then I can have the train model button here, right? So if I train the model here, then it will train the model with whatever tags I have already provided. This takes a bit of time given the complexity of the text, and given the fact that we have only right now for demo purpose I have just tagged 2 documents. So train the model, and then you can also do a quick test here, right? So quick test, improve model, meaning it will give you all the model metrics, and then you can compare and contrast, like what is the model accuracy. and then depending on that you can supply more information, you can supply more. In the improve model it will give you suggestions, right? So probably you miss tagging these entities, or do you think these entities are important or mistagged? Okay, and then you can improve and deploy your model. So this is so easy with doing this. So typically before custom entity recognition was there, how it used to work is you had to go to some third party annotation or tagging tools, tag your document and then train it, and then probably use it in your Azure applications or services, right? But here now, as you can see, this is all out of the box. So apart from your normal AI as a service from cognitive services, where you can check for named entity recognition out of the box, you can also train your own named entity recognition models. Okay, and also tag relationships between that. So let's say I have something like I defined entities. Okay, so I defined that is protagonist and antagonist. Now age, how do I know that this is the age of the protagonist? Okay, or this is the era in which the author was born, or this is the plot, or this is the city in which the protagonist stayed or the antagonist stayed. Okay, so these are relationships. So this is entities, and now there will be relationship between entities. Going back to our music thing, we have artist, we have music, we have genre, we have their albums. So artist was a part of album, artist plays instrument, artist produces a particular artist belongs to a band. Okay, or band is a artist is a part of a band. So these kind of relationships, right? So these relationships also we can represent in term of graph relationships. So extract the relationships from document and then dynamically represent them in graph as well. Okay, I'll show you that demo as well, the music demo with semantic search. Okay, so this is how you use custom tagging of entities. All right, okay, let me go back. Actually each of these projects is one topic in itself, right? And then we have this task of covering everything, I mean at least in a bird's eye view at one go. Then let us move on to classification, right? So classification, again I'm going to show you custom text classification. So I create a project. Okay, and then I have a whole set of data here. Again the same the movie plot point data I have. Okay, in which I'm going to tag each of them as a particular uh, class. Okay, so I have added classes for my plot points, my Wikipedia movie summaries. So I have love story, thriller, mystery, sci-fi, horror. I can keep on adding. Okay, I can keep on adding. So I added classes, and now each of them I'm going to tag it. So here the first one, where Danny is in love with someone, is a love story. Then here a woman in this thing, this will I'll have it as a thriller plus a mystery. Okay, I can have multiple tags. All right, it's not just single tag. Mine is a multi-class classification. So here, okay, I will say this is again a love story plus a thriller. Okay, then save tags. Next, and you can also click on next here, it will move here. Okay, so you can select it from here as well as you can click next and navigate, right? So then here it is a thriller and probably mystery again. Okay, I save tags. As you can see, then which means you are indicating how to, you are indicating how to. Okay, so this one is not a love story, this one is a horror. Okay, and you will see that how to indicate to a machine learning algorithm that what is the classes in which you want to classify text. So this is much like taking an image and indicating this is an apple, this is an orange, this is a pear, this is a banana. Okay, something like that. And then finally when you train your model, let us okay, this is again thriller. Okay, save tags. Okay, and then you can keep on tagging and then train the model. So once you train the model, okay, right, so here you can see that you have okay, here you have not met the minimum tagging threshold. So I think you should tag at least 10 to 12 documents if I'm not wrong. And then when you can train the model, it will train it. And same thing, you can test the model, give some movie plot point which is not present here and try to predict whether it falls in either of these five categories, and then you can correct the prediction as well. So it might predict it as sci-fi, but it is thriller. Then you can correct it saying, hey Mr. AI, this is not sci-fi, this is thriller. And then you can retrain your model. Okay, so all this is possible out of the box now. Got it? Moving back. Okay, it's going to move back. Come on. I should have a home page somewhere. Okay. So this is how you will work with the custom text classification as well. So actually, my suggestion is, if you can just go and explore this a portal, and there are a lot of things which you can just explore directly on the portal itself without you having to write a single line of code. So try the out of the box features with personally identifiable entities, key phrases, linked entities, named entities, and then you can move on to custom things like custom recognition or custom text classification. Okay, dynamic text summarization. So some of the features, mind you, are under preview mode. Okay, so they won't be available in production, but nonetheless they are available for us to experiment in the development environment. All right. So summarize text is a dynamic summarization of our text. Okay, so here if I say again English, okay, and how many lines of summary you want to give out. Okay, so three is default, so it will try to summarize in 3 lines. But other than that, you can choose. It can go from 1 to 20 lines here. And then order of appearances, from first to last, or ranking, like which sentences would you want to have first. So it's order of appearance or ranking from high to low. Okay, so again here also you can see your out of the box some sample templates. Okay, or then you can drag or drop your own file and see how it is summarizing. All right, so let us do that. We have enough of stuff which we did. So let us get let us get some extract about green energy. Okay, so renewable energy, let us get a Wikipedia extract of few sentences, and let us see how it is going to summarize it. All right, so here we go. We entered our own text here. Okay, let us remove these annotations or forget it. Let us see what it does. And then yeah, I run that, and it will give me results. I'm trying to squish it in a three this summary, three sentence summary, and it has summarized. Although most renewable energy sources are sustainable, some are not. 20% of global energy is renewable, including 30% electricity, and that there are 10 million jobs associated with renewable energy industries, with photovoltaics being the largest renewable employer. And as you can see, that it has decently summarized what I'm trying to say in like probably 20-25 lines. It is summarized into 3 lines, and it has captured the most important points about what I was trying to say. So this is a very powerful feature. It is powered by the inclusion of OpenAI GPT paradigm. Okay, BERT and OpenAI GPT. So the new cognitive language suite is all developed using OpenAI GPT. Okay, so yeah, just a glimpse into the things which you can do. And now we have seen things in isolation, like how you can do custom NER, how can do custom classification. Now it is time to see how the combination of all of these things comes together and works for an application. All right, so let us go and look at an application. There will be 3 demos of full-fledged applications here. So first is a music demo, which I kept on talking about for so long. So here is a semantic search. Semantic search meaning whatever documents I have, whatever information I have in my in my indexing engine, I will be able to ask questions about it, and it will be able to give me answers for it by searching my documents. So the answer may not be very apparent to us. The answer may not be very apparently available. It's not like a direct. Let's say, like for example, the past sentence we saw was like, XYZ was a 14-year-old boy, and then I will not ask what is the age of XYZ, right? It's not like that. It could be, the answer could be hidden in about 2 or 3 lines of 2 or 3 pages of my document, and then still the AI engine, the language service, is able to do a semantic search and come up with the semantic Q&A, semantic answer to my question. So which means if I ask a question and for which there is a direct answer available, it will not show me document links to search for my answer. So it will not say that these are 10 documents I found, and this is where you will find most probably your answer. If the answer is present in one of these 10 documents, it will directly come back to me with the answer. So the demo which we have here, what we have done is we have indexed around 300 documents of artists, their artists like bands like Beatles, ABBA, Spice Girls, etc. Okay, and then we are doing a targeted search on those the music data set. Okay, so we have a 2 to 300 data sets for artists, their albums, and their genre. Okay, so whether they are rock or pop or something like that. Okay, so let us try. So what are you searching today? So I'm asking who the Spice Girls. Okay, fingers crossed. Let us see if it gives me a targeted answer or not. Okay, and apologies for the slowness. I'm running this locally, as you can see. So it is connecting to Azure Cognitive Search, which is hosted in Azure in the West US region, and I'm trying to run this demo locally, right? Okay, so as you can see, the Spice Girls. Okay, so now there was a document talking about the Spice Girls, and it was in the form of the group list the Spice Girls, which is Mariah Carey, Whitney Houston, and Destiny's Child as their main influencers. So it has somewhere found the reference to Spice Girls. Okay, and then I'm saying who are the Spice Girls. It did not actually tell me who are the Spice Girls. Okay, but then it found some, with 97% probability, it found that the group lists Spice Girls as their influence, but it did not correctly understand my question. So this is where you can give it feedback, saying, hey, no, you misunderstood my question. I had asked you who are the Spice Girls, so you should give me the name of the Spice Girls. Okay, or like who are the members of the Spice Girl band. So wherein here you can give it a feedback and then ask it to reorder its search result, meaning that this is not the answer to my Spice Girls question. Okay, let us try another question. So I'm asking who are the members of the Beatles. Now let's see how it proceeds. Right, so now here you get a good answer, and with 99% probability, nonetheless, like the Beatles were an English rock band formed in Liverpool 1960, XYZ. Okay, and then they were integral to the development of counterculture and the popular music's recognition as an art form. Now let's say, if I try a question for which there is no semantic answer, which means it's a question but it is hard pressed to actually get a good answer for that question, then it will direct me to links of documents. Okay, so let me see who are the artists belonging to the rock or metallic rock genre. Okay, metallic rock genre. Okay, and then it doesn't understand the question. It might, it will, yeah, so it is redirecting me to, okay, it somehow refreshed the page, I don't know why. So it should redirect me to the search results, wherein I will be able to then do specific searches. Okay, so I can, so here as you can see, these are the entities which I have extracted from my documents, right? So the documents which I indexed, I have extracted genre, I have extracted albums, and I have extracted artists. Okay, so the files which I indexed, I tagged these these entities. These are custom entities which I have identified in my documents, and I have extracted them. Okay, so genre, and I have album, and I have artist, and I can do a entity map, which means I am also trying to extract the relationship between them. So which means artist belongs to an album, artist plays a genre. Okay, so these kind of relationships. So these are all taken out dynamically from my documents. All right, so now here you can say, for example, if I search Van Halen, okay, and I search for him, then all the great, there are no results for Van Halen. Okay, then I can search for, let me search. Okay, yeah, so there is, for example, yeah, let us search for, just let us search for Van, let us see what it comes up with. Right, there is Van Halen, but I think it was case sensitive. Okay, so Van Halen, and then it will give me, like, it will tell me that give me all the documents with Van Halen, right? So there are around 200 documents with Van Halen, and then it will also tell me that he, like, artists are also, for example, who are the ones which are associated with Van Halen, or the albums which are associated with Van Halen, and then what kind of genre music he plays. Okay, so that also I can search. So within Van Halen, I can slice and dice by all of these things as well. Okay, and then I can also view a entity map. So if you go here, entity map, I will be able to see all the relationships. So I can see Van Halen at the center. Okay, then maybe max nodes I will just reduce to 5, and max levels also you can see here. So how many levels of relationship do I want to see? Do I want to see only the first order relationship, which means something which is directly related to Van Halen, right? As either as a co-artist, as an album, or as his genre. Okay, so that you can see. Okay, or you can see second order relationships, which means Van Halen direct related to something, and then secondary order relationship. So maybe Van Halen was a part of the album Nevermind. Okay, and then there were other artists also which were a part of Nevermind. Okay, for example, Alice in Chains and Appetite for Destruction, these kind of things. Okay, so as you can see, you can dial down as much as possible to try to unearth the relationship between my entities, whether they are close related, whether they are directly related, whether they are related in second or third orders. And you can also increase the depth of the tree, so you can go as much deep as possible. And then you can also select the facets, which means in Van Halen, I just want to see the related artists for Van Halen. I don't want other information about the albums and genre. Then you can see only the artists which are directly related to Van Halen. Okay, let us reduce the nodes, and let us also keep the levels to 2 for us to be able to clearly see. So as you can see, Van Halen, I can only select now I can only see the artists which are directly related in some or the other way with Van Halen. Then I can also see only the albums which are related with Van Halen. Okay, so now as you can see, albums, yeah, so there are albums which are, it will give you the album. So Southern, what is that, yeah, never mind. Then Saint, Pepper is Lonely Heart, and there's something called as All Music. Okay, so it may or may not be a correct entity, right? And then Stand. So these are the albums, and then you can also click on the genre, whether it is Brit pop, rock pop, metallic rock, country music. Okay, so I will go to max level only 1. Okay, and then you can see that this is the type of genres which are related with Van Halen, like grunge and country music, southern rock, Brit pop. So this is very powerful, meaning it can tell you the relationship between your entities. All right, so this is how all of your classification, entity extraction, and dynamic summarization come together to form a intuitive search engine. Okay, um, I'm mindful of the time. Okay, so just a very quick 5-minute demo coming up for our health system. Okay, so as you can see here, okay, this is a COVID related search for using Azure Cognitive Search and all our fantastic NLP stuff. Okay, so as you see, if I'm searching, it will directly give me auto completion ibuprofen, and then documents which are naming the which are having the term ibuprofen, and also I can find documents similar to this, so this will also give me semantic similarity. Okay, and here also you can explore graph relationships, and as you can see here, the graph relationships also, what I'm trying to only see the contributors who have written papers mentioning ibuprofen inside them. So ibuprofen is as a central, and I can see that I'm only seeing the contributors who have primary and tertiary who have written papers mentioning ibuprofen. Okay, we go back, and I wanted to also show you that if I'm searching ibuprofen, okay, these are, see, now here we have so many entities. As I said, right, entities can run into like multitude of things. So here now entities are journal, okay, contributors, who are the contributors to papers which feature ibuprofen, which are the body structures which ibuprofen targets or treats, what are the diagnosis for which ibuprofen is used, what are the examination names in which you are using ibuprofen, what are the family relations where you treat using ibuprofen, like children or aged person, genetic structure for ibuprofen medications, and then medical, the class whether it's an anti-inflammatory or antibiotic, and then the names. Okay, so you can see so many entities are extracted, and the model is trained to identify these kind of things, and then this is how you will be able to explore the entity graphs. All right. Okay, so, yep. So, having said that, I think enough of demos. I still had a ML.NET Q&A demo to go. All right. But, yeah. So, any questions here? And was it clear all this while?
I was on mute. We don't have any question in the chat, but there is a lot of details that I guess each requires its own separate session to go through. But this is all interesting and very good use cases of a usage that we can like rely on. So it's at the same time it's using the like cognitive services search API
Yes.
as well as the language
Yes.
NLP as well.
Yes, absolutely. So all the searching won't be possible without the Azure Cognitive Search itself. So that is the backbone where we index all the documents. But just indexing the documents is not enough, right? I mean, on top of that, you have to do all of these language modeling, which is what is done using the language studio, Azure Language Studio.
Yeah, I guess it's a very backbone of knowledge mining solution.
Absolutely. Yes.
That is very interesting. I can see a lot of use case that we can use in industries. I'll let you carry on with the demo, with the presentation, then we'll wrap it up after.
Okay, so there's a very small part where there's a dynamic Q&A answering demo, okay, which we have made with ML.NET and BERT. Okay, again, throwing BERT into the mix, right? So this is your dynamic question answering, meaning whatever text you give it on the fly and ask questions about it, it should be able to come up with tokens. All right. So the only problem with this is currently an API format. We are still perfecting it into sort of place where you can actually give the question in a text box and get an answer back into a text box as well. That's why you see that I have to probably give it I mean the spaces have to be put in a URL format and suffixed with the percentile 20. Okay, so percentile 20 indicates space here to put it in a URL format. But let's say I am for example, whatever sample I create, so here I created a very realistic sentence for my one of my friends who had a injury to his knee while playing tennis. Okay, so the sentence is Amok fell down on the tennis court and had an ACL injury. He got operated on 20th of February. He is now in rehab. The surgery was successful. Okay, so what I said was he fell down and had an ACL injury. He got operated on 20th of February and he is now in rehab. The surgery was successful. The question was, question which we are asking for this particular text is why was Amog operated. All right, so you can absolutely give any text. I am just not in a mood to replace all my spaces with $20, I mean percentage 20. So let us do that. Okay, so let us give a context and let us ask a question. Okay, so let us give the context here. And I said that someone fell down and had an ACL injury, and why was he operated? Okay, so he was operated because he had an ACL injury, and the probability for having this answer is 86%. Okay, so as you can see here, the our dynamic Q&A bot based on your ml.net bot, much like the semantic search, is able to return me tokens as answers. Okay, so combining all the tokens will form my answer. So I asked that why the person got operated, and it came back with the correct answer, saying because he had an ACL injury and the probability was 86%. Why probability was 86%? Because the document did not state straight away why that person got operated. It only said that someone fell down, had an injury. The next sentence was he got operated, operation was successful. But he was operated for that injury was never, stated. That was implicit, which only probably a human mind will able to understand. But that is the beauty of our advanced NLP, right? So which is it was able to come up with an 86% confidence that the operation was probably due to the injury which he faced while he was playing tennis. All right. Okay, so this is again how you can orchestrate. So this is a separate topic for ml.net and BERT, right? An end to end, probably an hour long topic. Right, so probably some other day we reserve it. But yeah, again, because we also want a Q&A kind of an facility for our search engines, or for our bots, and which is also which is also built with the available with Azure Cognitive Services and machine learning.net. All right, so having said that, I come to the end of my presentation, and thank you so much for putting up with me for so long. I have been droning on and on. I hope that this was helpful to you and you find all these use cases useful, and probably you can get to use them in your knowledge mining, knowledge finder endeavors.
Thanks a lot, Priyanka. It was great presentation. I really love this studio. I'm playing with the Form Recognizer Studio myself, but I haven't got a chance to play with the language studio. It's the cool thing is the UI is kind of consistent, so I could
Yeah,
kind of understand. And the cool thing is that Microsoft offers is the pre-built model and template that you can use and see it in action right away without going through the hardship of setting things up. So it's really cool to see
right.
that things are coming together. And there is a lot to take in. I guess we have to set up another session with you to show us the ML.NET plus the NLP and see how that works together. But thanks a lot for your time. I know you've been busy and you're at client side as well. So thanks a lot for joining us.
No
I don't
problem.
see any other question in the chat, but we are sharing your contact details. So feel free to reach out to us as well as Priyanka if you have some follow-up questions. And I really hope to see you again, Priyanka, for other sessions.
Sure, sure, absolutely.
Thanks a lot. All right. We have a few more slides to go, and then I'll wrap it up. So our next meetup hopefully will be next month. We will announce the topic as well as the guest and the event date, but normally it will be at the end of each month. So, but if you're interested to share your experience or share your topics or any cool project that you worked on, please submit your session. We are always looking for great speakers such as yourself to help us to run the community. So please reach out to us if you have any sessions. You're more than welcome to join us. We publish and post this video alongside with other videos in our YouTube channel, which is we are part of Global AI Community, so you can find a lot more in regards to AI and ML topics. And you can watch this session again for at later time using that channel. So subscribe to this channel for many more videos and topics on AI and ML. If you have any feedback, please submit your feedback using this URL. We are always looking to improve, and we are always looking to make it better and have more that deliver more values to our end users and our audiences as well. So please provide us with your feedbacks, and we'll take all your feedbacks into consideration, and we'll try to improve our meetup as we go as well. And I guess with that, thanks a lot for everybody who is joining us. Hope you all enjoy your afternoon or your day, wherever you're joining us from. Thanks again, Priyanka, for joining.
Thank you, Somi. Thank you, guys.
Thank you. I'll see you all around for the next time. Have a good one.
Have a good weekend, albeit tomorrow. Thank you, everyone. Bye-bye.
You too. Bye, Han.
Bye.